Hello friends, this is Durga again from IT University. As you guys know, I run bi-weekly online hangout for certifications. For past 2-3 months, bi-weekly okay. Hangout. For past few weeks, I haven't conducted this session. Before that, I was conducting bi-weekly workshops. The reason why I don't have past two sessions is that there are some changes in the certifications, and I'm trying to adjust the material for that. And I will try to resume those workshops very soon. And I will include Hadoop administration stuff also, or big data administration stuff as well, very soon. And I will start conducting those bi-weekly workshops for certifications. That being said, today's agenda is primarily on different file formats and compression with respect to Spark. There is a reason why I am talking about this. If you go to Cloudera certification curriculum, Cloudera CCA 175, Spark and Hadoop Developers Certification Updated Curriculum. I May 1st or so, they started conducting a certification exam as per the new syllabus. And if you go to the new syllabus, one of the important thing which catch my eye is read and write files in a variety of file formats. And if you go through my earlier CCA 175 curriculum, even as per revised syllabus, I mentioned that it will be important, but I haven't gone into too many details. But now I got feedback from some of the folks saying that writing files in a variety of file formats is important, and they started getting questions on different file formats and also, more importantly, compression. That being said, I decided to create this video, and I will add this video to CCA 175 playlist, and also I will try to create a chapter in CCA 175 course, which I will be publishing very soon. So to watch this video in context with other videos as per the revised syllabus, you should go to the YouTube channel and go to this playlist and Hadoop developer. And this video is also added to this playlist already. Okay, so you will be able to see there also, and you have to watch everything to go and give the certification. And this playlist is primarily for time being, and also if you want to revise anytime, you can do it. But very soon I will have a course on itversity.com. I'm working on much better structure, and then I will try to plug in these individual components into the main course of CCS Spark and Hadoop Developer. Most of these things are still in progress, and it might take a month or so to get the content in the form of a well-structured courses. And if you see, I have a different file formats in Spark also as one of the lessons as part of this course. Anyway, you will not be able to see the content anytime soon, but within a month or so, I will try to come up with well-structured content. But if you are planning to give certification within next 1 month or so, I will highly recommend you to go through this interim playlist, CCS Spark and Hadoop Developer as per revised syllabus. Okay. So that being said, let's get on to the agenda. The agenda for this course is we will see how to read and write from text files, JSON, avro, sequence file, etc. And also we'll see different compression algorithms, how we can actually use compression algorithms. While text files will be demonstrated using RDD operations, file formats such as JSON, avro, ORC, Parquet will be demonstrated using data frames. Okay. and it's pretty simple. It's not very complex. There are many file formats, and everything can be accessed with a very handful of APIs, and some of the APIs are very similar. If you know one, you will be able to build others without any issues. That being said, if you have any questions while going through this, you can ask as per the chat, and I will be able to answer to you immediately. It will be given on the lab. So, as you guys are probably aware, ITversity runs a product called labs.itversity.com. As of now, we have big data labs in that, and I'll be using this. And for that, I am logging into the lab. Credentials, and these are my credentials, my username and password, and I will be logging onto the logging into the lab using my Mac terminal. This is my Mac terminal. Either you need to use PuTTY on Windows, or you can also click on this Open Console in Firefox or Chrome, and you can directly access through the web also. But web tend to be unstable sometimes, so better to use PuTTY or Cygwin or a Mac terminal if you are using Mac, Linux terminal if you are using Linux as operating system. Here, I am logging into the lab using the username, which is displayed as part of this page. And then yet, we have to give gw01.itversity.com, which is hostname. And if it prompts for the password, you just copy password and paste it. And to paste, you always use shift insert, whether it is PuTTY or in this console, you always use shift insert. Now I am in the lab, and let me start the Spark shell. So I'm launching Spark shell like this: master yarn and conf spark UI port 56213, just to pass a unique port number, because every one of us who launches the Spark shell has to have a Spark context running on a port number, and it will be better to give a unique port number like this rather than leaving it to default. And hit enter. Then the Spark context will be started. Let me validate that you guys don't have any issues watching the content. Okay, it seems to be going fine. So the Spark shell is being started. It will take just a moment, and then we will go ahead with the demonstration. So when the Spark shell is started, you typically get two context objects. One is SC, which is Spark context, which is nothing but a web service running on this port number, and the other one is SQL context, which is of type Hive context. Okay, so you can see the Hive context here. And for this purpose, I primarily use data frames. I will not use Hive context. Hence, I'm changing my SQL context to Spark native SQL context so that I can use data frames. For that, you have to say import org.apache.spark.sql.sql context. Okay, and then you have to create. Well, either you can overwrite this SQL context to this one rather than Hive context, or you can create a new context. Here I am trying to override it. SQL context equal to new SQL context, and SQL context takes the Spark context. It runs as part of the Spark context. So we have to pass this Spark context object, which is SC, which will be created when we start the Spark shell session. If you try to write the program, you have to programmatically create the Spark context, configuration, etc. And I have covered elsewhere, and you have to follow my earlier videos in the playlist to understand more about it. Okay, now the SQL context is created in org.apache.spark.sql.sql context. Okay, so now we have SC, which is Spark context. and SQL context, which is of type Spark native SQL context, which will provide us APIs for data frames. Now, let us start with reading and writing text files that we have seen as part of the earlier videos. You can go back and watch the content. Anyway, I will try to revise here. So when you type SC and then dot and then hit tab, it will show all the APIs that are available for SC. And one of a few of the important things to read the files from the file system is provided under this Spark context, and SC is of type Spark context. And if you see, there is a object file, there is a sequence file, and there is text file. These three are the out-of-the-box APIs to read different file formats using Spark context. Text file is to read data from text files, and we'll be using that later. Sequence file is a special Hadoop file format, and if someone asks you to process data which is in sequence file, you can directly use this one to read the data. And object file, it's a special Spark file format, and you can use it if someone says read object data from object files. You can directly use this API and you can read the data. Out of these three things, text file is more important because it's a lot more generic than sequence file or object file. So you can ignore, but try to do a couple of exercises on sequence file and object file. I will tell you how to do that also in a moment. But text file is very important and it's very straightforward. It's covered elsewhere and we'll be using later also. On top of these three things, there are a couple of additional file formats. One is new API Hadoop file, and the other one is Hadoop file. So Spark is just a distributed compute engine, and it does not have the file systems or file formats or file system-based APIs as part of the Spark binaries. Instead, it uses Hadoop. So when you actually try to develop Spark-based applications, and when you define the dependencies, it also download Hadoop-based dependencies, primarily the file system dependencies. And to access Hadoop file formats such as key value file format, n-line file input format, and few more file input formats that are available out of the box of Hadoop, you can use Hadoop file and new API Hadoop file. Hadoop file is primarily for older API which is being decommissioned, and new API Hadoop file is primarily for a new API. And again, if you go back through my videos, you will see a few examples here. And also, if you go to my GitHub code, Hadoop, PDW, Cloudera, Spark, and Spark Demo Scala. I have covered few. I think I have covered the new API Hadoop file format here. Save as, which means to write back to HDFS. To read, we have to use new API Hadoop file. To write, we have to use save as new API Hadoop file. I think if you go back through my videos, you will get enough material on these things. Okay, sequence file, new API Hadoop file, etc. That being said, so these are the which you need to be familiar: text file, object file, sequence file. These are direct APIs to read different file formats using Spark context while reading files in HDFS. And we have to read proprietary Hadoop file formats. And from certification perspective, they are not very important. Okay, the most important thing out of all these APIs is sc.text file. You should be familiar with it. And now let me demonstrate how to use this sc.text file. We have data in this location, public retail _ DB. This is HDFS location. And again, if you go through my videos, you will understand these things. I have covered many times as part of my videos. So you will be familiar with this. This is a publicly accessible data set, public retail underscore DB. It has multiple directories. One of them is orders. Okay, and this is how you can actually read files from a directory. Okay, so here I am saying val orders equal to sc.text file. It will read all the files from this location, and it will actually create RDD. And I don't want to get into what is RDD and all those things in this case at this time. It will just create a RDD, which is a distributed collection. And now let us see what all this sc.text file is capable of. For that, I am going to official Spark documentation. Okay, and if you see, this is official Spark documentation. Okay, and it is under the section external datasets. And here they are explaining about sc.text file. Okay, and one of the very important paragraph, and keep in mind that this documentation will be accessible to you if you are planning to give CCA certification or HDP-CD Spark certification. They both provide documentation to you, and you should be able to navigate through the documentation very quickly. Okay, so here this is one of the very important statement. All of Spark's file-based input methods, including text file, support running on directories. So here I am running on directory. If I want to read a particular file, I can give a file name also. Also, I can give the patterns like this. I can read files using wildcards as well. So in this case, it will try to read all the files with .txt extension. On top of it, okay, it can also read data from compressed files. You don't need to do anything explicitly to read data from compressed files. As long as the underlying compression algorithm of the files is supported, it will be read. You don't need to do anything special to read data from compressed files. Okay, so as long as the compressed files in this location contains files of type text file, we can use sc.text file to read the data. If you want to read compressed sequence file, the underlying files within the compressed file has to be sequence files. Then you can use sc.sequence file and read the compressed sequence files without any issues. Okay. That being said, now orders is after, and this is how we can read the data from the files and create RDD out of it using Spark context. And to write it back, orders dot, if you type RDD name dot and hit a tab, it will show all the APIs to you, and you focus on save as. And there is save as object file and save as text file. Okay, and then you don't see sequence file here because sequence file requires paired RDD, whereas orders is a plain RDD. That's why you don't see save as sequence file, but you see save as object file and save as text file. So if you want to write the output after you process the data completely, and finally if you want to write the data back to HDFS in text file format, you can say save as text file, and it will take care for you by writing it in text file format. Okay, that is about reading and writing text files. Now let us get on to the other file formats. What are the other file formats? I don't want to get into the details about explaining the concepts behind those things. You need to be at least familiar with the terms such as JSON. Okay, let me type it here. Avro, Parkway, ORC, etc. These are the main file formats which you typically see in big data systems or big data technologies: JSON, Avro, Parkway, and ORC. So you should be familiar about how to read and write in these file formats. Okay. So now comes data frames into action, because on Spark context you don't have these APIs. You need to use data frames to explore these options. And I don't have any JSON data or avro data or parquet data with me. So first I will try to write RDDs or data frames in the form of JSON or other file formats, and then I will try to read. First I will try to write, and then I will try to read. So let us see how to write in a particular file format. For that, first I need to create a data frame out of my input data. Okay, so here what I'm trying to do is, for the orders, I'm trying to create a case class. Okay, if you go to the data model, orders have 4 fields, and I'm naming it as order here. Okay, and the 4 fields are order ID. Again, if you go through my course, you will understand all these things. If you are doing it for the first time, you have to go back and follow the videos instead of directly watching this isolated. Okay, first field is order ID. Second one is order date, which is of type string. Third field is order customer ID, which is of type int. And fourth field is order status, which is of type string. Okay, now the case class is created, and I want to create a data frame use. And again, you have to go back and understand why we have to create case class and to create the data frames. I have explained extensively as part of the earlier videos, as part of this playlist, CCS, Spark, and Hadoop Developer. Okay. Okay, so let me paste the playlist as part of the chart so that people have immediate access to it. Naresh, now you can go to that playlist. So before getting into the data frames, make sure you watch this data frames and Spark SQL video. That will make a lot of things clear, why I am creating data frame, etc. Okay, now I have created the case class, and using the same sc.text file, after reading the data, if you want to create the data frame, also you can define a new variable and start invoking APIs on orders, which is of type RDD, but I was itself to create the DS also. So sc.text file, I have given the path to read the data, and I have to apply map transformation so that I convert each of these string in this input data into an object of type order. Okay, so text file will read each line as one record, and the data is comma separated. Let me say orders dot collect or take. I'm just previewing the data for you. For each println and hit enter. You can see the data is comma separated, and pass this string and create a order object. Okay, for that I am using this one. Here I have to use map function. Rect is of type string, and I want to develop a multi-line code. I have started curly brace, and then I am creating a new variable called r equal to rect dot split comma. Now, when this is invoked, and the output of this split will be an array. Okay, and then I want to create object using that array. So how can I create? I can invoke case class by saying order like this, by giving the class name, and the first field is order ID, and it is of type integer, so I'm casting to int. Second field is string, so I'm leaving it as string. Third field is again int, so I'm saying to int, and fourth field is again string. Okay, and this will create RDD for us. So the snap function will take care of creating RDD of orders. As created, we can invoke 2DS, which will convert RDD into data frame. You can see it here. Nurse is of type data frame. Once it is created as data frame, if you type the variable name tab to see the APIs, the most important API with context to today's discussion is write, because we are trying to write into different file formats. And let us see where the write is. It's the last one. Okay. And then if you type write and hit enter, it will create something called data frame writer object. Okay. And if you again hit dot and then hit tab, it will show you what all file formats it can write to. Okay. So it can write in text format, it can write in ORC format, it can write in Parquet format, it can write in JSON. You can also save into tables by using save and save as table. You can use JDBC to write into JDBC. You can use any custom format by saying format also. So orders.write, which is nothing but data frame writer. Orders is of type data frame. That's why write is exposed to it. If it is just RDD, you will not see this write option. Okay. And data frame writer have APIs of all these things. For us, as part of today's discussion, the most important are JSON, ORC, and Parquet. Okay, we need to understand how to use avro also, but avro is not available here, and we will see how to access avro as well a little bit later. So for now, let us try to use Parquet. So we can say Parquet, and we can give the path. The path has to be HDFS path /user d Gajaraju is my HDFS directory, and here I want to write orders in Parquet format. Okay, and that's it. Data will be written in the Parquet format to this location. And if you want to write it in JSON, you can just say orders.write. JSON. And then you can say JSON. Okay. So and if you want to write queries on top of this data before writing in Parquet or JSON format, you can register on the data frame. You can register it as a temp table or view, and you can run queries, and the output will be data frame itself. Okay. For example, instead of saving directly like this, I want to process data and then write. Okay. So what do we have to do? First, we have to create. We have to take the DS, which is orders in this case, and then we can say register temp table. Okay, and then we can give the name of for the table. In this case, I am giving table name is also orders, and these two can be different. The data frame name and this thing can be different. Okay, so let us try to process the data. Let us see how many orders are there by each status, and then we will try to save that output into this into JSON or Parquet format rather than directly write orders. That will put in a perfect context, especially when you have to execute tasks as part of the certification. Okay. So now orders can be accessed using SQL. That you can actually test by saying SQL context dot SQL and then select star from orders limit 10. I'm just previewing the data and then apply show. Okay, there is some issue with this. Okay, I know what is the problem. I have to import SQL context dot implicits dot underscore. No, this is not the issue. Let me see why it is failing. It is complaining table not found. Okay, orders dot show. Yeah, it is working. And then orders dot register and tables. Let me give it as O. For some reason, it is not able to access this temp table. Let me see the syntax. Probably the syntax might be incorrect. I am opening a new tab here. Anyway, okay, I think it came back. Okay, let me open this one. Okay, I know what is the problem. So here, I think when I created the data frame, I have to put the brackets in the end. I think that could be the issue. Okay, so I'm copy pasting this one to df. Okay, and now let me register it as temp table. Yeah, so you have to be extremely careful. Make sure you put brackets in the end. I was also surprised for this. I don't know the difference between the two. Anyway, now you can see the data. Now let us try to create a new data frame by getting count by status. So here I am saying orders by status equal to SQL context dot SQL select order status comma count of one count by status. It is alias for the column from orders group by order status. Okay, and hit enter. And you can say orders by status, and the output is of type data frame. Okay, whenever you perform any operation on data frame using SQL context, the output also will be on the data frame. Now you can say show and get the sample, and you can see the data. Now let us write this back to uh, uh, the uh, the HDFS in JSON format or Parquet format, whatever it is. You can choose whatever you want. For this purpose, I will try to use JSON. Okay, so I can say orders by status, which is of type data frame, write dot JSON. Okay, and then I can give the path, which is user D Gadiraju orders by status JSON. Okay, so I am connecting to the lab in using another session so that we can preview the data in that output in the path we have given. Okay, this is the path which is given. Okay, and we can see the output in JSON format here. Okay, it has created 200 files because by default it uses 200 tasks to process the data. Actually, reduce it by saying SQL context dot set conf spark dot SQL dot shuffle dot partitions to 2. In this case, I want to set it to 2. Don't use the default one. Okay, and then I'm removing this directory. Okay, now it is deleted. Now I am writing back again. Okay, now it has written. We can do ls and see only 2 files. And then I can say Hadoop ss-cat on one of the file. You can see the output in the JSON format. This is the JSON format where you will have column name and value for each and every record and its attributes. Okay, so here this file has 2 records and the other file have, I think, 6 records, and overall all the records are preserved in these 2 files because we have given shuffle partitions as 2. So this is how you can write in the JSON format. Now it's very straightforward. Orders by status dot read dot JSON, and then so for this also you need to you have to create SQL. Sorry. Um, 1 minute. Okay. This is not how we should read. Reading is a little bit different. Let me see. It will not work because yeah. So reading should be done using SQL context. Okay, because we have to pass we have to pass the input path, and then we have to use SQL context or Spark context to read the files. So Spark context is to read the files in regular text format. If you want to use this read to read other file formats, you have to use SQL context. And if you say SQL context and then dot and then hit tab, you see read here. So we have to use this read to read it back. So instead of first reading and then writing, because I don't have the files in the other special formats, first I have written the data into HDFS. Now I'm trying to read. To read, we have to use SQL context, and this SQL context has to be native SQL context. I'm not sure whether Hive context have this API called read, but native SQL context have. Okay, SQL context dot read. And then if you hit tab, it will show all the supported formats, and JSON is one. And also we have Parquet, ORC, etc. Okay. Now you can use JSON and you can give the location. And to preview the data, you can just say show and you will be able to see the data. And if you want, you can also register this to a temp table, and you can actually run SQL queries also. Anytime you can convert a data frame into a temp table. So for that, you just have to say register temp table. Let us give it as X. Okay. Now you can say SQL context dot SQL select star from X. And then show. And you will be able to see the data. So this is how you can read from any file format using SQL context object dot read. It supports several file formats out of the box, such as JSON, ORC, Parkway. These three are very, very important for certification purpose. You can also read text data using SQL context. And if you want to use some other third-party format, you can have a generic API called format, and it requires to pass class name and all those things, which is out of the scope for today's discussion. That being said, one of the important file format that is kept and very important, especially for Cloudera certification, is avro file format. Okay, because Cloudera comes out of the box with avro. If you try to use this, if you try to explore this on a Cloudera cluster as part of SQL context.read and dataframe.write, you will also see avro option. But with Hortonworks cluster, avro is not integrated along with Spark, hence you don't see that. For that reason, if you want to practice for the certification purpose with avro as well, what you have to do is you have to start your Spark session, something like this: Spark shell -- packages, then com.databricks /spark avro _ 2.10 2.0.1. Okay, to get more details, you can go to Google and search for Spark avro. Okay, so here I am searching for Spark avro and go to Databricks repository of Spark, and you will get all the details. And this is the compatibility table. From 1.4 to 1.6, we have to use 2.0.1, and for 2.0x, we have to use 3.2.0. So don't try to use this directly. Make sure your version is compatible. That's why in this case, I said Spark shell -- packages. com.bricks is the group ID, and this is artifact ID, Spark avro _ 2.10. We have 2.10 Scala. That's why I'm trying to get Spark avro built with 2.10 Scala. And this is the Spark avro version, which is 2.0.1, which is compatible with Spark 1.6. Okay, so I'm pasting this also to the chart. Okay, and then you can say master yarn also conf spark.ui.port equal to some 5-digit number, some random 5-digit number. It will register the dependencies, download the dependencies with the session you are launching, and then you will be able to explore avro also. Okay, so let it create. So let me complete the lifecycle with avro format. First, I will try to read the data from orders, and then I will try to create a data frame. I will write it into avro format, and then I will read it back from the avro format and display the results. I will try to complete the entire lifecycle, which I have covered earlier with JSON, with avro as well. Okay, first thing what you have to do, you have to change your SQL context or create a new context by pointing to arg.apache.spark.sql.sql context. Sorry, here I have to say new, and then I have to pass Spark context to it. Okay, so this is the command. You should not use this one. Ignore that. This is the command which you need to use, or you can import this one first, and then say val SQL context equal to new SQL context of SC. As long as you imported this SQL context, it will work. Once it is done, the next thing you have to do is create a case class for orders. Okay, so I'm copy pasting the case class which I have created earlier. Once the case class is created, I want to create the data frame. That is the first thing, because I don't have any avro data. So first I am writing data in the form of avro format. Okay. So for that, first I need to create the data frame. Write is available only on data frame. It is not available on SQL context. Read is available in SQL context. Okay, and now I created the data frame, and then let me register this as temp table. Register temp table orders. Okay, and then create a new data frame where we will get by running a query to get orders count by status. Okay, again, what happened? Orders dot register temp table. Table not found orders. Okay, I think import SQL context dot implicits dot underscore. Okay, and then let me run this again. And then let me register it as temp table again. And then let me, okay, I know what the issue is. So it doesn't matter whether you put brackets like this or not, but the main issue is you have to import implicits dot underscore, and then you can run your query. Earlier also, after importing implicits, I did not rerun this. When I rerun by adding these brackets. That's why I thought brackets is the one which is making difference. That is not correct. The difference is the actual steps are, I will reiterate the steps. First, import the SQL context and create the SQL context object pointing to Spark native SQL context. Create the case classes, and then first import the implicits, and then you actually process the data, creating RDD of type order, and then data frame out of it, and then register temp table, and then you are good to go. So this is the order you need to follow. Okay, so I'm running again in a proper order, just to make sure that you don't have any confusion. So first thing you have to take care is creating the SQL context pointing to native SQL context. And I will highly recommend to immediately import this one rather than delaying it. Once you import SQL context, you can create case class. Okay, and then you can process the data and create a data frame out of it. Okay, and then you can register the table, and then you can actually run the query and create the data frame out of which will be the output of that query. Now everything is good to go. Now if I say orders by status dot write and dot tab, okay, even though avro is exposed, it might not show up here. It could be the bug in Spark Shell or whatever it is. I don't know where the issue is, but even though avro is not shown here, you can give a try. Okay, it is not even auto-filling. And now I am giving the path as slash user slash dgajraju slash orders by status avro. Okay. It worked earlier. I don't know why it is not working now. Okay, I know why. I have launched the session with the package, but I did not import. That's the reason why. So you have to run import com dot databricks dot spark dot avro dot underscore. So you have to import this package. Now you will be able to run this. Importing, so with respect to Cloudera, you might not have to do this because avro is available out of the box. As we are using Hortonworks and we don't have Spark, avro Spark avro integrated with the Spark, we have to launch Spark Shell with the packages the way I have done and also pasted in the chat like this hyphen packages, the group ID which is com.databricks, artifact ID, and the version. And then you have to import com.databricks.spark.avro.underscore, which will import all the APIs available in that package or all the classes available in that package. And now if you take this path and run it here, avro data will be stored in binary format, so data cannot be, need not be readable. Okay, so don't worry too much about it. Here again, it created 200 files because of the number of Spark SQL partitions, Spark SQL shuffle partitions. We can actually run that command to change it. Okay, so I'm deleting this one. Okay, and I'm running it again. Okay, now it ran, and we can see there are only 2 files in that location, which will contain the data. Data will not be in readable format. The only way to validate is use SQL context dot read dot avro and give the path. Okay, and then show. It will confirm that you can actually read the data. You can also say register temp table and issue queries against the data as well, as I have demonstrated earlier. So this is how you can play with the different file formats. Now let us talk about compression. Okay, so most of these file formats, Parquet, Avro, should be used in conjunction with the compression, and you might face the questions about using compression wherever you are trying to use this file format. So in that context, if you have to compress the data, you don't need to do anything other than whatever you are using as part of APS, but you have to set a parameter in which you define the compression algorithm. So if you have to compress the Parquet file format, let's go to the Spark official guide. Okay, and go to data frames, datasets, and SQL, and then search for compression. So this is the parameter spark.sql.parquet.compression.codec, and default is gzip. And the data will be compressed automatically for you. Okay, so whenever it is Parquet, data will be automatically compressed in gzip. If you want to make it uncompressed, you have to say uncompressed. Okay, if you want to change it to snappy, you have to just change it to snappy. In case if you want to use avro and you want to compress the data, you have to use parameter called spark.sql.avro.compression.codec. If it is ORC, you have to say spark.sql.orc.compression.codec. So let us see it in action. So I am deleting these files again, and then I am actually setting the parameter spark dot SQL dot, in this case avro dot compression dot codec. If it is Parquet, you have to say Parquet dot compression dot codec. Okay, and there is no compression codecs for JSON, etc. So you need to understand the difference. This compression codecs will be available for Avro, Parquet, and ORC. These three are the ones. You can give a try on all the three and make sure that the data is compressed the way you want. So in this case, I want to compress in snappy format. I have to use conf, not cont. There is a typo. And then I am writing the data. Data is being written, and we can do ls in that location. Okay, it is showing only .avro extension. We are not sure whether data is compressed or not. Data is not compressed. Okay, let me see whether the let me change it to gzip. Okay, and then let me delete it. And then let me, okay, compression gzip is not supported. So with Avro, gzip is not supported. Only Snap is supported, and I think Snap is default for Avro. That's why when it was Avro, it did not fail, right? So even though the extension is not flowing, but still the write is successful. So by default, it might be compressed with Snappy. So let me say uncompressed here. And now let me write it and see if it works. So even uncompressed also does not work. So it has to be compressed when it comes to, okay, directory is already existing. So let me delete it and then run it again. Uncompressed. Now the data is being written and you can see the output. The sizes are different. So by default, when it is Avro, data will be compressed using Snappy. If you want to uncompress, you can say uncompressed, and you can provide any supported compression algorithm. Okay, and when it comes to Parquet, the compression is default, and it will be compressed using gzip format, and you can change it to Snappy or LZO, whatever is supported. So this is how you can use the compression. You don't need to worry too much about anything. You just need to make sure that SQL context.setconf actually pointing to appropriate compression algorithm. We can also validate the values by saying SQL context.getconf, and then we can say spark.sql.orc.compression.codec. If you want to just review the compression codec algorithm. So ORC, there is no such compression codec. So for ORC also there is no compression codec. Only for Avro and Parquet it is available. We can say Parquet here and let us see. Parquet by default is gzip. Okay, so now data is compressed, and if you want to read the data, you don't need to do anything else. As long as the underlying compression algorithm is supported and the underlying file format is in line with the file format you are trying to read, in this case it is Avro, we are good to go. We can just use this same command on both uncompressed data or compressed data, as long as the data is in the Avro file format in this case. Okay, so this is how you can play with compression also on top of the file formats. Once again, the supported file formats out of the box are, you can just say SQL context.read, JSON, ORC, Parquet out of the box. And if you want to use Avro, you have to start the session, especially on the lab, with the packages pointing to the appropriate Databricks package for Avro. And then you can use any of these file formats. Make sure you practice a lot on JSON, Parquet, ORC, as well as Avro. Okay, and sometimes they might give input in the form of JSON, and you might have to preserve the output in the form of avro, or they might give input in form of Parquet, and they might want you to save the output in the form of JSON. You just need to distinguish your read pattern and write pattern, and you are good to go. Okay, it's pretty straightforward. In case if they ask you to read it in Parquet format and write it in JSON, use SQL context.read.parquet to read the Parquet data. And once the data frame is created, use the data frame.write.json to write it in JSON format. If the compression has to be enabled, you just have to say setconf and try to use the appropriate compression algorithm for reverse file format. If it is Parquet, default is gzip. You can pass snappy and other values as well. And you don't need to do anything else except for invoking the write with appropriate file format using which you want to write the data. So that being said, I will take few questions. We already passed 7. Very few questions I will take, and we will wrap up for the day. And one of the question is, any reason you are covering 1.6 rather than 2? Still 1.6 is highly relevant, and this is primarily for the certifications perspective, which is and both Cloudera as well as Hotworks certifications are being conducted on Spark 1.6. That's why I'm covering 1.6. So I didn't run in local mode, I ran in yarn mode. Whether you run it in local mode or yarn mode, I think the default number of executors is 2. I'm not sure about the local mode, but in yarn mode, the default number of executors is 2. Okay, that being said, that's it for today, and thank you very much for joining the session. This video is added to the CCS Spark and Hadoop developer playlist towards the end of it. Make sure you watch it, practice it before taking the certification, because there is a huge emphasis on these file formats lately. You get better at it so that you can face the certification with a lot more confidence. And best of luck for all of you guys. That being said, if you like this video, please click on the like button. If you want to provide the feedback, please use the comment section of the video once the video is streamed. And if you want to share with your friends, just click on share and share on your social networking platforms. And if you need environment to practice, always go to the labs.itversity.com and sign up for the lab, and you can practice. And if you have any questions, please go to discuss.itversity.com and start logging your technical questions here, so that your questions are addressed by our volunteers. That being said, thank you. Bye.